scatter. Before this, I will do a quick introduction about our company, NI. Jindo, can you share your screen? For the first page. And second, sorry. Okay, please allow me to do a quick introduction about my company, NI. NI invests in transportation and the automotive industry about 20 years. We provide a testing platform for our customers to validate their product in lab and also in production line. For the current EV cars, we focus on many domains like ADAS, powertrain, battery, BMS, V2X, IVI, infotainment, and also body chassis, this fusion domain. But today we will focus on battery BMS only to introduce our HIL topic to you, and we want to collaborate with you in MIH working group. For the car design process, the OEM and Tier 1 will start from pure software testing. So Jindo, can you change to the next page? Okay, as you can see on the picture, from left to right, we start from the pure software testing simulation to right, physical testing. It's our R&D and the OEM Tier 1, they follow this this process to design, validate, and produce their products. And in the product validation process, HIL, hardware in the middle, is very important to validate EV cars, subsystem, and components. So we will validate the product performance, reliability, and safety on the HIL platform. So HIL platform is very important for automotive industry. It includes the whole EV car, also subsystem and component. For the next, I will invite our HIL engineer Jindo to introduce more about the HIL system and our platform to you, and our topic. I pass to you, Jindo.
Okay, thank you. I'm sorry, I need to transfer to Chinese.
谢谢，没问题。
接下来由我介绍，就是今天 NI 带来这个 proposal， 我们是讲这个 Power Level 的 Battery HIL。那在讲这个之前呢，为什么会去提这个 Power Level 这个 HIL？首先我们去了解到市场上现在在做，就是刚才安古斯有跟我们讲到的一些测试方法，它存在一些痛点。客户的痛点是什么呢？比如说我们在做 Signal Level 的 HIL 的时候，看到我们蓝色的这个框框里面，他们一般是针对于 Signal Level HIL， 只针对于 BMS 控制器去做它的算法的以及部分硬件的测试，但是它这个测试里面是不包含电池包的，也就是说你不能去测试，在这种测试层级里面是没有办法去测试到真实电池包的一个状态真实电池包的一个好坏。那么还有对电池包目前测试的话，我们会是去用这种传统的这种冲放电机去做，也就是我图中显示的这个地方紫色框框上面这张图冲放电机它会对整个电池包去做测试，但是呢它却不能去对 BMS 的一些逻辑做测试，而且它也没有办法反映你电池包装车之后的一个状况那装车之后用什么去测呢？就是需要去实车测试去测。那这实车测试我们知道，看这个图中从左到右这个整个设计过程，它是在整个测试的最后，也就是说你车辆成型之后，基本成型度好，它才能做这种测试，它是很后期的一个事情而且这个东西时间成本和这个财力都是一个很大的一个消耗，所以它也有它的缺点，就是尤其是在做东标和下标测试的时候，要跑到极南极北的地方去做这种测试，成本还是很贵的。那有没有说一种测试方法，我们既可以测试电池控制器 BMS， 也可以测试电池包，同时呢，我们还可以去兼顾一些实车的这种测试，就是我们把实车的一些测试搬到实验室里面，在实验室去制造这种极冷极热，还有一些各种工况下的一些条件，有没有这样一个测试方法可以在实验室阶段做呢？那就是我们今天带来的这个 proposal， 就是 Power Level 的 HIL。所以这是一个从 Signal Level 的一个传统的测试到 Power Level 一个测试的一个过渡那这里我其实做了一个对比，就是刚才提到的几种测试方法第一个就是我们的这个 Signal Level 的这种 HIL刚才也讲到，它有优势，就是它可以完整的测试 BMS 控制器信号级的这种逻辑，包括它里边的这个软件算法都没有问题，而且它可以很容易的去设置一些极限工况的一些测试这在 HIL 里面都可以极其容易的去实现。 但是它的劣势就是我的电池包并不是测试对象，我并不能测到电池包的这个状态啊。那我们今天在 MIH 提出的这个 Power-Level HIL 就可以解决这个电池包不是被测对象的这个问题啊。除了刚才讲的这个闭环测试之外啊，我们可以结合场景啊、道路、车辆模型，这个稍后也会有介绍啊。它是为了去更加真实的仿真车辆在路上跑的一个状态建的一些场景啊。这样的话就可以去更加真实的反映车辆装车之后，你的电池包跟车辆作用到一起之后，它会是一个什么状态啊？这种测试可以去做，而且它还可以通过温箱，我们去制造冷热这种天气，甚至这个不同的阻力、道路阻力，来去实现你这个路测一部分代替你一部分路测的这种功能啊。这是我们今天，所以这是它的一个优势。今天讲 Power HIL 的一个优势。那在对比更传统的这种 Power Level 的测试的话，往右边，我们传统充放电机，我们知道这个就是拿一个 cycler 去给它做这个电池的电源以及做电池的负载，给它充电放电。它有一些循环充放电，我们在各类国标里面都会有这种要求啊，但是它只是标准的这种国标测试，它不能反映装车的这个状况。对，然后实车测试其实刚才也有讲，就是我们没有办法去在很前期的时候，车辆设计前期就去做这种实车测试，没有办法的，只能等车造出来之后，我们才能装车去做测试，这已经很后期啊，这个而且成本很贵。对，那这里其实对比完之后呢，我觉得大家心里应该有个概念，那就是 Signal Level HIL 和这个 Power Level HIL 它有一个明显的区别，就是电池包到底是不是我们的被测对象啊？我们要不要测这个电池？包括这个整个系统未来跟这个车辆结合到一起之后，我们看是一个什么状态啊？那这个都可以在我们 Power-Level HIL 里面去做的。整个系统今天带来的是一个什么样的一个架构呢？我们有3个部分啊。首先 NI 最传统的是中间的这一部分，就是我们有一个RT 系统实时系统。那这个实时系统里面其实可以当做是我们整个系统的一个核心，它里面去运行了各类的模型以及控制整个系统的控制啊，这里面包含了车辆模型，然后以及各类这个设备的一个控制。那再往左边的话是我们的一个场景软件，这个场景软件里面所有的这个交通道路标志以及行人车辆都是可以自定义的，也就是说你可以自定义一个固定的一个场景，然后让它去在这个场景里去跑，然后呢我们去验证这个电池在这个过程当中它的放电的一个特性啊。那在右边这一部分就是我们传统的这种 cycler 的这种形式。就是这个充放电机的这个架构，那么包含了一个 cycler，就是包括它是去给这个电池充电和放电的啊，电源和负载都是它。那么中间这个其实是一个温箱，那我们可以看到温箱里面其实是放了整个 pack 进去，包括 BMS 也在里面全放进去的，就整个测试对象全放进去。我们通过温箱去给它去控制不同的温度，以及这个主要是控制不同的温度，对。然后水冷它是去模拟这个电车这个车上的这个水冷系统啊，它是直接接到电池里去做水冷的。所以整个系统来看的话，就是有 NI 的 RT 系统作为核心，然后还有 Windows 的这个上尾机做场景软件，然后还有我们整个功率级的这一部分的这个测试。分开来说的话，就是 NI 在这个 RT 这一部分呢，我们这里有一个概念就是车辆模型，我相信大家可能比较好奇，那为什么说这是我们 NI 这个自己的一个优势呢？就是因为我们在这个平台里面，它有不同层级的这种仿真模型，不同层级、不同速率的模型都可以在我们这个平台上去实现。那从最快的来说的话，就是我们 FPGA 层级的纳秒级的仿真。然后我们再往 CPU 去，如果这个模型不需要这么快，那我们还可以在这个 RT 的这个 CPU 里仿真。然后如果还可以再慢一些，那就是可以放到这个 host 的上位机里去做一些这个仿真。当然，这些不同层级的这种仿真平台，只是为了做什么事情，在我们这系统里，去为了满足不同客户对于仿真的需求。那仿真在我们这个整个系统里是一个什么位置呢？它是去我举一个具体的例子，就是我们这个系统它是一个更加开放的一个平台，也就是说我们不针对于某一个车型，那不同的车型在我们这儿怎么去做测试呢？其实 只需要去建立不一样的车辆模型就可以，比如说 EV 的乘用车、HEV 乘用车以及 PHEV 乘用车，以及这个 EV 的商用车，这些车辆都可以在我们平台上去仅仅通过修改模型然后来去实现对于不同车辆的适配。这个意义在于是说，一个是复用性，设备的复用性，另外一个是说同一辆车，那比如说我们在做一辆 EV 的这种乘用车测试，但这个车是在不断的迭代研发的过程当中，那么它车辆的结构会在设计的过程当中随时去变化。那这个时候你如果在实车上去测，那你就需要去把这车造出来去测，很麻烦。但是在我们这儿只需要去对车辆模型进行一个修改，改一个参数，整车装备质量去修改一下结构参数修改一下，摩擦力系数改一下，那在这里就可以实现你的车辆虚拟化到了我这个平台里面。对，然后这是我们这个 RT， 然后 Cycler 这一部分的话，这里也是 NI 的一个标准的 offering， 它其实就是为了给电池去做充放电那整个来看的话，我们整个系统里面会有一个温箱，然后会有一些这个 measurement rack有 Cycler 和 measurement rack。measurement rack 主要是去监控我们电池充放电过程当中的温度、电压、电流这些传感器信号，把它实时的记录下来还有一个 chiller 去对电池进行水冷的它主要是受刚才我们的 RT 的系统去控制的，这是 NI 的一个标准 offering， 软件硬件也都是 ready 的一个状态，现成的。对，然后接下来就是我们这个系统里边一个亮的一个点也是就是讲这个 scenario， 这个 scenario 其实就是我们如果看到他们搞 ADAS 那个方案的话，会看到有场景仿真。那这个场景仿真里面的这个车辆呢，其实就是我们的备测车辆我们的电池你就可以认为它是在这个车上装着的。那这个场景里的车所有的运行的这个加减速以及这个转弯以及这个各种路况，就是上坡下坡这个颠簸砂石甚至说你可以加一些交通元素这个行人，然后车辆拥堵的工况、红绿灯，这些所有的交通元素对于你车辆反映到你的这个通过摩擦力反映到你的这个阻力上面对你这个车辆电池的一个消耗的状况，都会实时的去反映到我们整个系统里那这样的话就可以给我们就是带来其实是一个路测的一个虚拟化。原来都需要去开车到路上去做这些测试，我们都可以在场景里面把这个相同的条件搭建出来之后，在这里去做一个虚拟化的一个测试代替很多实车测试的这个工况。那我这边基本上是刚才三个部分。那因为今天时间也有限，我再 echo 一下，就是前面这些我们今天这个整个方案的一个优势以及可以做什么它 Power-Level HIL 的功能呢，其实它是主要服务于 OEM 和 Tier 1的这个研发部门它可以做传统的充放电机的这种测试各类国标里要求的充放电测试可以做，而且它兼顾了 HIL 的功能仿真，然后我们可以在这个虚拟环境下进行这个车辆的一个电池相关的一些测试，而且它还可以去做这种代替东标和下标测试这种很费时间的这种路测代替部分。那么我们整个具体来讲，就是这边实现的一些这个优势呢，我们就是包括刚才这个讲到的我们闭环的 BMS 这个算法系统的这种验证在这个带了更真实的电池，而不是说 Second Level 的话，它没有真实电池，它是一个电池模型，这个电池模型不够真，它没有办法验证的更全、更完美。那带了真实的电池之后，我们可以验证的这个 BMS 它的这个整个逻辑会这个验证的更加的充分、更加的真实然后而且它可以去跟其他的系统去联调，比如说我们讲新能源3电BMS VCU， 然后还有这个 Inverter MCU 这个它都可以去联调的然后还有就是真实工况的模拟，我们通过这个对于温箱的这个，我们会有环境温度模型，然后去对温箱进行控制之后去实现你东标和下标测试当中的这种温度工况，而且这里的平台是各类这个条件都是参数化的，测试条件都是参数化的，包括车辆模型、路谱数据，就你的道路的这个平坦度这各类数据吧。然后路谱数据，然后来适配你各种 车型以及各种道路、各种工况而且在我们这个里面有一个比实车测试更有优势的地方，就是我们可以做一些这个虚拟负载，做这种极限工况测试。因为我们的 Cycler 用的是这个虚拟负载，那这个时候我们就可以做这种去量化这个不同的负载对于一些危险工况的这个负载状况，对于这个电池包冲击的这种风险的评估，可以去做这种量化，这是实车做不到的。整体来说的话，这个方案会去节省我们的成本，以及加速未来的这个上市周期，这是我们的一个优势未来的话，其实这个平台还可以往后去扩展讲到这里呢，其实我们主要是在 battery 这部分测试，但是其实有一些客户他还会去想，我们整个 battery 未来有没有可能去再把这个 inverter 和 motor 动力和传动的部分都加进来？那这个其实是可以和 dyno 的测试台架去做一个结合的这里我举了个例子，这儿是一个这种整车加进来的然后它这种方式就会是说我可以把整个车以及这个整个车的这个 dyno 这个放到我们的温箱里面，那这样的话整个车带着就是主要还是我们 BMS battery 再加上这个inverter motor 再加上传动，这些都会成为我们整个系统的测试对象，开到我们这个温箱里面这样也就是可以去做一个battery 加 dyno 的一个扩展的一个测试，这是我这边今天带来的一个 proposal 的一个方案安格斯，我交还给你。
我们交还给 Eric， 看有
Okay.
没有什么问题。
Thank you, Angus and Jindo, for the remarkable introduction of battery hill, power level battery hill topic. So we'll have open questions in the final and in the very final. So we'll continue to our next topic, which is digital twin in EV, introduced by Kathy and Delhui from Microsoft. So I give it to you, Kathy. Thank you. So Kathy, you're on mute.
Hello, can you hear me?
Yes, please.
Okay, so let me pull up my deck here. Okay, so first of all, thanks so much for having us. And myself and Hui, we are representing Microsoft and from the customer innovation team for Asia Pacific. So today we are going to share with you our view regarding how to building the energy agility through the digital twin, essentially for the electronic vehicle. So the slide deck here you are seeing, I think that's kind of aligned with what Eric just introduced, the working group for MIH. So I have the honor to represent Microsoft to co-chair the working group in energy management, battery, and BMS, and agree. So in past few years, my team, we has the privilege to working with a lot of automotive and also high-tech manufacturer in this region. And we realize the EV electronic vehicle has been a hot topic for the industry. So we see there's a lot of crossover between the automotive industry, high-tech manufacturer, and also the energy green industry. So for today, I want to starting from Microsoft view how to taking the digital twin as the foundation technology and to build to help the electronic vehicle for creating a more agile electronic grid. So let me move to the next slide. Okay, so while we are looking at the energy agility and through the e-mobility service, so basically And our friend from NI, they just give a remarkable introduction about the BMS system and through the simulation system, right? So just like our friend they introduced in the later part. So starting from the battery itself, but what we are looking at to extend the impact, not just for the battery pack, but also extended to the vehicle and also extended to outside the vehicle. So when we look at the energy agility, basically we're taking from the free persona point of view. The first of all, of course, the car itself and the battery itself. So what the whole industry is looking at, especially for the car manufacturer, people want to having a better control of the battery pack and want to increase the performance. But also a lot of like car manufacturer also looking at how to really build the modernization of the battery. So that's the first persona. And second persona, as a driver, as a buyer, I would say that's maybe the first, the most important part is when I'm driving electronic vehicle, my biggest concern is always range anxiety, right? So I don't want, I don't want to, having like a range anxiety while I'm driving. I do want my car can be really drive to the destination I want to drive for, right? So basically, as a driver, I want to know where will be the closer the charging station, and am I able to reach my destination, with the power I'm having in my electronic vehicle. So how to better to having the better service to assist the driver. That's basically the second persona. And the third persona, of course, to a lot of power plant like Thai Power or the rest of the power plant, and EV car for them, in the surface, it seems like it's kind of burden. So like Taiwan Power Company, they kind of worry will be the increasing the electronic vehicle demand will create a lot of burden for those for their power supply. But in the same time, I think a company like a Thai Power, they are also looking at maybe EV car could be another opportunity for Taiwan to create more resilient power supply. So thinking about the battery could be a small like a storage, right? So when Taiwan is kind of like in the shortage of the power, and maybe those the EV car, they can recharge, they can sell the power back to the grid. So smart charging infrastructure, that's another persona we are looking at. So just like Eric mentioned earlier, in terms of the capability, so that's actually the target we want to achieve through the working group. So the battery management system, the connected vehicle to provide the telemetry data back to the digital feedback loop, and EV charging platform V2G, V2H, and also the virtual power play. That would be the key capability we want to achieve through the working group. And regarding the technology, so we're going to talk more about how to apply digital twin into those to increase the energy agility. But it's actually combine all kind of like a metaverse technology, that's including device management, IoT, machine learning, AI and cognitive service, and of course, road condition, how to combine the satellite data and the map condition into the whole e-mobility system. So achieve that, we see there's a needs to really create the electronic vehicle digital feedback loop. So you need to really combine all the data through the four entity. The first entity, of course, driver, right? So the data you need to collect from driver is basically their customer portfolio and how will they drive. Will they have a rush start or they just drive like very moderately? So the customer portfolio and also the driver behavior, that will be the data you need to collect into the digital feedback loop. And secondly, just like our friend from NI, they talk a lot of how to do the simulation. And of course, you need to really collect the data from the battery itself, and also as well as the data from the vehicle, including the motor, including the control system, and charging station, charging infrastructure, and utility. Those are the key entity we need to really collect the data, get it into our digital feedback loop. But in return, I would say the most important thing is how can you really build in the deeper relationship with your driver to help them to solve the range anxiety and to ensure that they have the best deal while they are finding the charging option. And of course, to provide back to the battery supplier or the automotive maker, help them to to making some progress in terms of battery innovation, and also back to the utility and the charging infrastructure, the ecosystem, right? So what I want to highlight here is when we are thinking about to create a digital twin, what really matter is not just battery itself. Actually, we also need to consider the four parts, that's including driver, vehicle battery, and charging infrastructure, as well as the utility company, right? So with that, I will hand over to Dehui. She will going to share with you some of the practice and the use case. I think that would be better to help you understand how to apply digital twin into those scenario. So over to you, Dehui.
Hey, can you guys hear me?
Hello,
Hey,
we cannot hear you.
can you hear me?
Yeah, a little bit, but
right.
a little bit lower.
All right. I'll probably
Yep.
get started then. So I think thanks, Kathy, for sort of introducing the concept behind it. And I'll probably use a couple of use cases as well as customer references that we have done in the past, just kind of give a bit more context and also, I guess, more grounded examples around how, EV digital twin may be something that is, critical here to be able to support the entire ecosystem. So the page that you guys would be seeing right now is essentially why digital twin for EV, why digital twin for EV battery in particular, right? Because having said that, we needed this whole digital twin feedback loop is one thing, but what answers, what questions can we get answers to is also very, very critical. So we'd like to give a few examples, right, where digital twin is super essential in being able to answer some of the questions that may be very, very important, not just from a battery maker perspective, but also really to answer some of the questions like as a driver, to Kathy's point, the whole anxiety range part. So some of the typical questions that, a lot of our customers, when they work with us on EV digital twin, battery digital twin, they tend to want to get some ideas around, hey, what was essentially that piece of information if I go back in time and I look through it, and how does that impact the way I look into my batteries that are health? So example, right? What was temperature in the world that may have impacted me in terms of my battery consumption? What would have been, the nearby sort of EV charging station that I could sort of reroute myself to, and so on and so forth. These questions, right, are essentially the questions and reasons why people care and people want to build the digital twin for EV as well as the EV battery itself. And I guess, a lot of people then ask questions like, so, hey, how does the technology then support this? And the technology behind this is essentially some of the key services around digital twin. And the way I guess Microsoft kind of looks at it is that digital twin is responsible for essentially two things. One is, how do I model the battery and the battery components within it? How do I model the EV car and the components behind it? And then how do I respond, right, to the different event handlings? So let me give you a few examples just to make it really real. As Kathy also kind of highlighted earlier on, it's not just the battery itself, the BMS data that would contribute to all the different situations that you need to handle. It's really about the driver behavior. It's really about, the charging infrastructure that I can get my hands onto. It's really about how I respond and coordinate myself within the V2G consumption to the grid and utility itself as well. So the data sources and the information sources and the modeling sources tends to come from a variety of places, as you can see on the left-hand side. But why is that essential? Again, it helps us answer questions that you saw on the previous page, which then brings us to the right-hand side of this picture, which is, what are the additional business inquiries that I'd like to get answers to? What are the additional simulations that I would like to get, addressed? So for example, if my vehicle was running in a very particular manner by a very particular driving behavior under certain weather conditions, how would the range, how would the state of health, how would the end result of my lifetime usability end up to be? Those are the questions that a lot of OEMs, not just from a car manufacturer, user driver behavior, like to get responses to. And I think that's essentially the role, why digital twin is so essential here. This is just a quick glance, not to explain everything, but how would a digital twin may look like in a real world example. So taking this gas plant example and sort of thinking about how this may map into a car or battery example would be each of the nodes that you see here may represent a very particular component or part. And each of the component parts are linked to one another by a relationship, by the lines that you can see here. So it may be the, let's say a battery pack, it contains certain cells and compositions, or it may be the vehicle itself that contains the, powertrain or the battery or the different components that mix it up. But essentially, by having this model, by having this relationship nodes, it gives us the ability then to answer and ask questions to the digital twin. For folks who are slightly more technical and I guess familiar with SQL language, right? It then gives an opportunity for many of us to ask questions directly to the digital twin by asking select statements to the digital twin to be able to get inquiries on the data that you wanted out. So just to get into some examples, so very recently we actually had a really good collaboration that we did with the Hyundai Motors in Korea. Hyundai Motors, essentially what they were trying to do was that they were trying to understand, especially from a battery pack perspective, right? What is the state of health? What was the state of charge? And what is the remaining usability of the lifetime of the battery? And therefore, they thought, hey, why don't we have the composition of this in a digital twin representation? And adding on to that, right? How do we apply then the AI technology so that we can predict and simulate what is the what-if conditions of each of these battery packs? Because essentially that would then give them a way to be able to give the confidence to their end users as well. To Kathy's point, the driver range, how much do I still have to go before I need to go to the next charging station, or how much before I can go before I need to sort of deprecate this particular battery pack itself. So that's one example using a car OEM perspective. This other example is not a customer case, but it's rather just us trying to imagine, right? What if the possibilities there are if we think about it both from a battery maker perspective and also an OEM perspective. This is just an sample idea that we're thinking of, and also hearing out from our friends from NI and maybe early on some of the other folks as well. So from a battery maker perspective, there's a lot of things that they have been collecting from BMS primarily. There's a state of charge, state of health, but to what Angus and also colleagues from NI has already also mentioned early on, there may be additional data acquired right from the battery, from the vehicle itself, from a driver perspective, or even the conditions of the drive that they're under, the grail conditions of the roads, the icy conditions of the road, and so on. But there are also any other external influences like weather conditions, road conditions, which maybe folks like TomTom can add on to the richness of the data that can be collected. All of these, on one hand, we said it's useful for the battery maker because it gives sort of that state of health, state of battery resale value out there. But if you combine, right, the different battery makers, where it's coming from, potentially Foxconn, potentially BYD or CATL, it also gives them an opportunity to work with the EV automotive OEMs to be able to look into, I guess, what many OEMs are interested today, which is recycling business. They're looking at consistency in terms of comparison. They're looking at what's the best mix and match in terms of the composition from the various battery makers. And I think what they are really interested from the battery makers as a result of having all this data is how do I, have a better recycle price? How do I have a better customer satisfaction as a result of all of this? So this is an idea and this is sample. But I'd like to turn back to Kathy because I think for her closing, she would probably go into some of the example works that we may actually look into as a working group. So Kathy, over to you.
Yeah, so sure. This is my last page. So basically, I use this very busy page to really try to imagine what the effort in front of us as the working group, right? So as we describe about create a digital twin across the four entity, the car and battery itself, and the driver, and also the EV charging station, EV charging infrastructure, and utility company. So start from to really create the digital feedback loop. You need to set up the data exchange standard between the driver, between the vehicle, and as well as the road condition, and also able to connect to cloud because that's allow us to really doing the data exchange and also to leverage the computing power over the cloud, do the AI and also the predictive maintenance, prediction capability. So starting from, we also need to having this data exchange standard to be established. But in terms of like application and just like we illustrated earlier, so there is a multiple application need to build up. So our friend from NI, they just illustrate the BMS system and also the how to simulation. But we know to really collect the data, you also need to collect the telemetry data from the vehicle, so connected vehicle, and how to collect data from the EV charging platform, and as well as the like V2G, V2H, and the virtual power plant. So I consider that's a kind of application. But we know to support that multiple application, and we know there's more is coming, we actually need to provide API. But also to provide the API, is we actually will need to having the so-called data contextualization platform, because that's allow those the startup and also the new application builder to just leverage the API and also the contextualized data we provided through our platform, which allow them to really more having the capability and also the environment to develop the new application. So just like I put in the top hand side here. So what I am expectation or what I will propose is when we start to working as a working group during the MIH, I think first of all, we also need to having the reference architecture for the different application catalog. But we also need to encourage into driving for the so-called reference implementation. And with those the reference implementation, let's allow the whole industry, we can learn what would be the best way, what would be the more efficient way to create the open API for contextualized data. But I also want to highlight here because people always thinking about AI can solve everything, but the thing is, how can you really contextualize the data? Because in the end of day, they will just illustrate the twin graph, right? So how to really build a model of the different entity, because we know the whole EV industry is very complex, right? It's just not battery, it's not just vehicle itself. You also need to accommodate the data from the cloud, from the other party, right? So how to really describe the relationship, how to describe the problem you want to solve, right? So which I put in the middle here is we also seeing there is some AI company, the startup company, who is very dedicated into that domain to create a so-called knowledge graph for vehicle and the battery. I think we also need to put together those the innovation effort together to leverage the domain knowledge, which if they already establish the knowledge graph or the contextual data, I think we should just leverage that instead of build our own knowledge graph or the data model. So that's one I want to call out here because it's very important. Once we are able to really understand the domain and understand the relationship between the different entity, I think that's allow us to most rapidly to develop all those applications, and that would definitely will be accelerate the joint effort for the EV grid development through the MIH. So with that, thanks for your listening and attention. and maybe we can take some further question in the last. Thank you.
Yes, thank you, Kathy and Hui, for bringing up such a remarkable introduction regarding to digital twin. We think that the digital twin will be a very precious data, and that can be used for further virtual and reality integration in the next in the EV development phases. So and then for the following next, I am going to introduce the three topics. The first one is open BMS. Okay, so as you knew that what MIH is promoting the open platform, and which under this open platform, the participant, the partners can jointly work together to make the platform better. So in order to that, so we are also doing the standardization of novated in software protocol or in hardware components in software and both in hardware. So open BMS, one thing we are looking at the architect that we want to be a standardized in open way. How do we do that? So in this architect, you can see that the left side is the standard battery hardware structure. So we can see that we want to separate into modularized design, including the protection, including the BMS parts, something like that, to make it that could be the standardized components and can be replaced, with each other's different suppliers. But we most likely is that the software part right now there is no structuralized or standardized architect. So right now we in the right side we reference there's a reference from Hopper Fox BMS. They structuralize and organize the BMS software into different layers, such as they have safety operating areas, doing the safety controls, and also have a self diagnostic layer, so that it can do power safety check, something like that. And above in the application, so they can provide a battery's status estimation, something like that. So by doing that, the open BMS hardware open and software open, so we can compatible. What our target ultimate goal is that we can use this upgrades this modularization design to improve the overall vehicle efficiency. Okay, so what we're doing planning in hardware modularization is that since we have a car right now have different design, low voltage or high voltage, low voltage, different cars. So when we want to design, we're aiming designing a high low voltage compatibility hardware platform. And also one of the most important parts is that the peripheral compatibility. For example, the cables for the 800 volt, for the maybe higher voltage like 1,500 volt. How can we define a compatible cables in different voltages, different usage? So that's something we want to do the hardware modularizations. And in software modularizations, we're working especially on the data interoperability. Because for right now, if you want to improve the open BMS, or improve the efficiency on BMS, to calculate the SOX, everything, state of everything is only mainly on the rely on the information in the battery itself, like in cell or in the pack. It did not consider the external information like from the navigation, what the road condition is. It's upcoming, it's uphill or downhill. We don't have the right information could be inputted to BMS for better estimation of the mileage or do a better control of the vehicles. Same thing, vehicle VCU. Well, the information right now is not linked. So we are planning that we are building an open API and a common data set. That is, the navigation can pass the data, the road conditions, to the vehicle or to the BMS, so that BMS can use these informations to have a better understanding, better estimation, and better usage of the power of the vehicle. So this is the snapshot. It is a reference from TomTom. They have ADAS Map, so we can see that they can indicate the road information, including the curvatures, including the gradients, including everything, the traffic signs, something like that. So we can use this information as some parameter and input as a to BMS for BMS to calculate. One thing is the real mileage that can be that the vehicle can drive, and also maybe the driver behavior. For example, like drive fast or a regular driver, so they have different power consumptions in different driving mode. So we can use this as the estimation, and also can provide a more efficiency driving or power electricity usage to the vehicles. So that's something right now we are doing. So in order to do that, we need to do a advanced. We are doing the advanced system of state of everything estimation. Traditionally, they are using some on-the-shelf algorithms, mathematical algorithms to do the SOX estimation. But right now we are advanced. We are adopting AI into the SOX estimation calculations. So before, also we need, in order to you adopt the AI calculation, AI estimation. So we are building the digital twin, battery digital twin that Kathy and Dehui just mentioned. So we are, also right now the vehicle data is unstructured wise. Everywhere but unstructured wise. So it's different to when you put on in the database and how to read that. It's not unstructured wise. So we are working with Microsoft using their DTTL, discrete language, digital twin discrete language, to define the data in the vehicle, in the battery, and into a structure wise data, so that we can use it input as an input for the AI for the modeling afterwards. So this is something we are doing right now in the BMS topic. And next, I'm going to introduce what we are looking at, the high voltage cable design and specification. So we are also doing at the hardware specification definition as well. So not only in the vehicle, but also in charging stations as well. So we can see that we are working on a high voltage cable specification definition. Traditionally right now, it's the charging station or is using up to 800 volt. And also some in the middle, it's from their Porsche, their Blueberry model. They even use as high as 1000 voltage right now. And some also looking, heard that there are some trends use higher, like 1500 volt to do the charging. So in order to that, the cable must has strong resistant standards for different voltage, especially for higher voltages. So the left side down here is the performance of why the OEM tier ones wants to use high voltage charger, because the you double the voltage, double the watt, but the performance getting much better than double. So that's why they are aiming higher voltage usage in the cable and in the vehicle only, in the vehicle as well. So in this topic, we are going to do the defining a high voltage cable and connector standards. Okay, with safety and reliability design. For example, high temperature resistant. We can do the 800 volt or 1000 or even higher volt. How to make the cable how to assure that the cable can resist from the high temperature, and also the shielding for the interference. Because when you do the charging or discharging, the magnetic interference may infect the digital components in the vehicles, especially for EV. There will be more and more digital components in the vehicles. So how to do that to keep the signal inference? How to do the design, the shielding is what we're looking at this as well. So not only the cable. Cable is just an example we are doing. So we're also looking at the like the inverter. Is that modularized? Can be do the standardization, do the modularizations, and of course in vehicles OPC, onboard charger or anything can be modularized. Can be some standards. So this is something we are just taking just as an example for you to indicate that we're doing something similar here. So Adam may have questions, but I'm going to finish my next one. So I would leave the questions when I finish. All right. We have open questions in the very end. Thank you. And the last topic is wireless charging. So as you can see that we are also looking, recently we saw many government working with OEM tier 1 starting doing the wireless charging on ground. But one is on the road and the other is stationary charging stations on the ground as well. So we are looking at these two wireless charging standards. We knew that there are already some stationary charging station standard like J254. We're looking at that as well. So we are doing that. What we are aiming at, we want to define a wireless charging standard in Taiwan, compatible with the other international standards, work with them as well. So how we help Taiwan government or local suppliers here, to build a national wireless charging wire or wireless charging grid or infrastructure as a guideline for the government to adopt, to follow. That's something we want to do also in the wireless charging topics. So these are some topics we are working, not limited to these topics. And I think the most important you want to know is that how we collaborate. So here is the model we are working temporary right now. We think that it could be improved, but our initial thought right now is that we can starting by the topic proposal like wireless charging I just mentioned, like the high voltage cable we just mentioned. Then we have an internal review under some committees. We have experts from university, from industry, from government help us to do that review to see, hey, it's a good question, it's a good topic that we want to work, that is needed. Also, the reviewers also from some of the reviewers also from tier 1 OEMs as well. So then since they approved, once they approved that topic is interesting as worth of doing, so we can do the team recruitment, which means this topic may need more other parties to participate as well. Then we kick off the project. And MIH can help to do the external resources allocation, like, for example, we can together apply external project, or we can do the third party, invite third party to help to join the project as well. Then kick off the bidding. Then usually we have a project demo at end of this year. So we'll deliver the project. We'll deliver October demo, that's for sure, and also then. By the demo, we define some MIH standards, and of course comes up with the IP, which could be shared among the members as well. And then of course the last thing is that we will push this project go to market, since we have multiple participants from OEM tier 1. We will push that this could be adopted to some vehicles as a product. So that's what we are trying to. Help the partners to manipulate, monetize the solution, the efforts they built in the working group, and go to market for each component, each parts for each partners. So this is the collaboration model. Right now we are aiming. So I think this is finish my introductions with NI and Microsoft. So because of time strain, I think we can have like 10 minutes or 3 questions if we have, and you can ask MIH, NI, or Microsoft. If you have a question, you can just ask. Yeah. Any questions? Okay. Correct. Adam's on call. I'm not sure. Adam, do you have a questions? Okay. If no questions, I think all right. We'll have if you have any questions online, you can send me online. You can send to my email here, or MIH will put the send the question list questionnaire. You can ask online as well. After the meeting, we'll send a question email that you can raise your question here. So I think this is the end of sorry, Chris. Any questions? We have a question from Chris.
Yeah, it's not a technical question. Thank you for the presentations today. I just thought I'd ask if the presentation decks would be shared and also the recording of the meeting. Apologies, I'm a bit new to this, so sorry if that was a basic question.
Sorry again. Sorry, I cannot hear you clearly. Sorry.
Oh, okay. I was wondering if the presentation decks would be shared and also the recording of the meeting.
Yeah, the recording of the meeting will shared on the internet, and the material we'll check that later if we will see if we will release on the internet on our website.
Okay, thank you.
Okay, and Michael Chung.
Eric, just want to check if DuPont interested to participate the project like 800-volt cable and also wireless charging. Then what is the next step? Are you going to send us meeting notes when will be the schedule for the meeting, or I mean, how to participate?
Sure. So anyone, thank you, Michael, for raising this question. This is a quite question. I think for any participants, any partners who want to join any topic, please email me, contact me directly. So then I can arrange in the next meeting. I will arrange you to join that once you become once you become a contributor member, and they can join the working group discussion in the next meeting starting I think we'll set up 2 weeks later. We will have a bi-weekly meeting for the participant members to discuss the topic, to discuss to do the update. So please email me, and I will do the follow-up with you separately.
Thank you.
Yeah. All right. If no question, no more further question, I thank you very much for your time today, and thank you. And if you have a question, just email me. Thank you very much. Yeah. Bye bye.
Thank you all.
Thank you. Bye bye.
Thank you.
Bye.
Bye-bye.
Bye-bye. Bye-bye.
Bye bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye bye.